What we are finding is both fascinating and deeply unsettling. Researchers originally wanted to use Webb to gain a better understanding of the formation of the first stars and galaxies, but instead they are repeatedly encountering phenomena that push our established models to their limits. From early galaxies that are far too massive to black holes that shouldn't even exist yet to chemical signatures that could turn out to be extraterrestrial biosignatures, Webb regularly reminds us how many secrets the cosmos still holds. But that's not all. Some observations even suggest that the universe is not as uniform as we always believed, and that could shake our cosmological worldview. So what has Webb discovered, and why are these findings causing astronomers such difficulty in explaining them? Stay tuned until the end and find out with us if you like. The James Webb Telescope hit the ground running. While it has since become famous for its numerous impossible discoveries, its first images already gave a glimpse of where the journey would take us in the coming years. Webb's first deep-field image, SMACS 0723, showed thousands of galaxies in a tiny section of the sky. More precisely, in an area about the size of a grain of sand viewed with outstretched arms. However, many of the galaxies photographed appeared surprisingly large, structured, and almost fully developed, even though they existed only about 400 to 500 million years after the Big Bang. According to our previous models, the structures in this early phase should still have been chaotic, but Webb showed that everything was different. As a result, our understanding of the young cosmos had to be rethought almost immediately because a $10 billion piece of equipment proved that the youth of the universe was not quiet and slow, but produced objects that we would not have expected to see until much later. As we now know, this was only the beginning of a series of even more confusing observations. Soon after, Webb detected early galaxies that should not have existed in this form. Just a few hundred million years after the Big Bang, some of these galactic premature babies were almost as massive as our Milky Way is today. And that should not be possible. With the help of the James Webb Telescope, we are looking deeper into the universe than ever before. But according to the standard model of cosmology, there simply was not enough normal matter at that time to pave the way for galaxies of this magnitude. It usually takes hundreds of millions of years for stars to form, heavy elements to be produced, and galaxies to develop recognizable structures. Well, at least that's what we thought until then. True to the motto, one mystery rarely comes alone. Black holes then came into play. Astronomers found active galactic nuclei in some of these structures. Black holes that were already devouring matter even though the galaxies themselves had barely had time to form. The question was how these cosmic giants could have formed so quickly, and researchers are discussing several scenarios. One of them is based on black holes that were formed practically directly by the collapse of large gas clouds without these having formed many stars beforehand. Another possibility is that star formation in the early universe was extremely efficient. In other words, denser gas, more frequent collisions, and faster processes led to accelerated growth of galaxies in their central black holes. Signs of extraterrestrial life. A look at alien planetary worlds. Now, however, the James Webb Telescope is not only examining the mysterious large-scale structures of the distant cosmic past. It's also turning its sharp infrared gaze on alien planetary worlds. Previously, we could only observe exoplanets indirectly, mostly in the form of brightness fluctuations caused by them passing in front of their host stars. Webb, however, is capable of directly analyzing the atmospheres of exoplanets, and the case of K2-18b shows just how significant this is. Located about 124 light-years away from us in the constellation Leo, K2-18b orbits within the habitable zone of its home system. What's more, the celestial body is also suspected of being a genuine ocean world covered entirely in water, and Webb detected water vapor, methane, and carbon dioxide molecules which indicate processes that could be conducive to life. The real sensation, however, was a detection of dimethyl sulfide, or DMS for short. After all, this substance is produced on Earth exclusively by living organisms, more precisely by microorganisms in the ocean. In view of this, the discovery of DMS on K2-18b is also considered potential biosignature, and thus a red-hot clue to extraterrestrial life. But other exoplanets also revealed surprising details. WASP-39b showed water vapor and carbon dioxide, while WASP-18b presented extreme atmospheric conditions that turned our idea of planetary weather upside down. Webb offers us a first opportunity to examine specific chemical fingerprints in the atmospheres of distant worlds, bringing us step by step closer to answering the question of whether we are truly alone in the universe. A look at the solar system. Surprises on our doorstep. As an astronomical jack of all trades, Webb also has our home system in its sights and has captured the mighty Neptune in unprecedented detail, among other things. In fact, Webb has provided us with the sharpest images of the ice giant in over 30 years. And we can see not only its fascinating rings, but also its poles, cloud formations, and even weather phenomena that were previously invisible. It's as if we can really read Neptune for the first time. But the bottom line is that Webb is not only looking at the large planets, but also at much smaller outgrowths of the solar system. These include, for example, the asteroid Cheriklo, which excitingly has its own tiny ring system. However, why the two companion rings exist and remain stable is still unknown. What is known, however, is that Webb has detected water ice on the surface of the chunk, and in combination with the rings, this gives us new insights into the composition and dynamics of smaller objects in the outer solar system that were not previously possible with this level of precision. No less interesting is the study of Europa, one of Jupiter's icy moons. Webb has discovered active water vapor fountains shooting out of the surface, once again supporting the assumption that a liquid ocean slumbers beneath the ice crust of this celestial body. And let's be clear, this is not just any tranquil pond. It is a subglacial sea that can contain more water than all of Earth's oceans combined. The fact that the cool water remains liquid there despite an average surface temperature of minus 70 degrees Celsius is due to several factors. On the one hand, the gravitational forces acting on Europa generate friction inside the moon, which in turn generates heat. On the other hand, the hidden ocean contains salts and other dissolved substances that lower the freezing point. The decay of radioactive elements in the rock core could provide additional heat, making the moon not only an extraordinary object for researchers, but also one of the most exciting places in the solar system when it comes to the question of extraterrestrial life forms. If these are ever discovered on Europa, it would naturally be a huge sensation. But Webb pays attention to even the smallest objects. Accordingly, the telescope was able to detect water on comets such as 238P Reed, but in some cases no carbon, which provides us with important clues about their formation and early chemical processes. Trans-Neptunian objects were also observed by Webb, enabling measurements of methanol and simple organic molecules for the first time. All these investigations show us that even familiar worlds on our doorstep still hold secrets, and that we now have a tool to uncover them. A strange discovery. Do we live in a black hole? Returning from the relatively small to the large, we see that Webb has already raised questions that challenge our holistic understanding of the universe. More specifically, this refers to an astonishing observation made as part of the JADE study, which shows that approximately 2/3 of the galaxies observed rotate clockwise and only 1/3 rotate in the opposite direction. This may not sound particularly spectacular at first, but in reality, this rotational imbalance stands in stark contrast to the fundamental assumption of isotropy. After all, in an isotropic universe that looks the same in all directions on a large scale, there should be no preferred direction of rotation at all. But what is the explanation for this? Well, it's not entirely clear, but some researchers believe that galaxies rotate in a preferred direction because we are inside a black hole. If our cosmos was born inside such a massive monster, it could have passed its angular momentum onto us. The extent to which this is true is disputed among experts. But what is undisputed is that Webb's observation at least prompts us to re-examine the previous image of a uniformly ordered cosmos. Incidentally, this also applies to our idea of a calm and uniform early universe. Let's just take a look at the so-called Sleeping Beauty galaxies, which stopped producing stars within 1 billion years after Big Bang. So they were active early on and then suddenly stopped shining. And we cannot say with absolute certainty what this is all about. The only thing that is certain is that stars, galaxies, and black holes were apparently formed much faster and more intensively than previously assumed. We now know of planets with potential biosignatures, and many established models of the early development of the cosmos need to be rethought. In just 3 years, Webb has changed more than anyone could have expected. And in light of this, we quickly forget that the biggest surprises may still be ahead of us. The most powerful space telescope ever built will continue to deliver data for years to come, and may uncover further structures that seem unimaginable at this point. The way has been paved, and we can look forward to discovering what breathtaking secrets we will unravel in the future. But before we get to that, let's talk about why you click the subscribe button. Just press the thumbs up and subscribe to never miss a new video from us again. See you soon.